All right, continuing with the quadratics practice test. Again, if you just want to check your answers, scroll to the very end of the video. I'm going to start with number 12 through 20. Number 12 says graph it and use your y-intercept to do so. So that's a -8. So I'm going to put 0, -8. And that helps me to find where it crosses the y-axis, which is right about there. Axis of symmetry, we do -b over 2a. And the b is 2, so that would be a -2 over 2 times 1, which is 2. That becomes -1. So -1 is my axis of symmetry. That gives me that dotted line where the vertex is. It's about right there. The vertex, I plug in this x value for all of my x's. So it would be y equals -1 in parentheses squared plus 2 parentheses -1 minus 8. Do order of operations, we square the -1. -1 times -1 is +1. And 2 times -1 is -2 minus 8. 1 minus 2 is -1 minus 8. So we get y equals -9. So that would be -1 comma -9 for my vertex. So I go left 1 down 9. And it's going to be somewhere around there. Zeros, I'm going to set this equal to 0 and factor it. So x squared plus 2x minus 8, and I'm going to make that as 0. So x squared plus 2x minus 8, let's see if that was correct. Yes. And set it equal to 0. I'm going to try to use AFM, so 1 times -8 is -8. Bring down the +2. What can multiply to give me -8? I'm looking at 4 and 2. One of them needs to be negative, so the 2 needs to be negative. Lead coefficient's 1, so all I need to do is write x plus 4 and x minus 2. And I'm going to solve it for 0. So -4 plus 2, that's going to be -4 and +2. Those are the two spots where it crosses the x-axis. So I have -4, -2. So I go left 4, put a dot, and go right 2 and put a dot. And then I'm going to connect all of my dots. And remember, this should be symmetrical. It should be folded in half along the axis of symmetry. Okay, number 13. An object is blasted upward at initial velocity of 180 feet per second. So I know it's going to look something like this. The height of the object is a function of time. And I'm looking, that looks backwards to me. So I could rewrite it -16t squared plus 160t. And then there's no y-intercept there, so it's, well, there actually is one. It's 0 since it's not there. So I can rewrite that function in standard form so it makes more sense. How long will it take the object to hit the ground? That's going to be the 0 of the function. Question B, how high will it be at 2 seconds? That's going to be the vertex. And that's the y part of the vertex. What is the highest elevation the object reaches? I take that back. Question B says, how high will it be at 2 seconds? We don't know if that's the vertex. That would be for C is going to be where it's the vertex. Sorry about that. So that's the vertex, the y part. For B, we plug in a 2 for x. That's when x equals 2, because our time is x. Part D, when does the object reach its highest elevation? That's going to be the vertex, the y part. In other words, it's just the axis, the x part. That's just the axis of symmetry for part D. All right. So, I am going to use my calculator. All right, I pressed y equals, and then I typed in the function. I hit second graph to tell me what I needed to do for my window. I adjusted my window, and I made my x-min -2, my x-max 12, because I know it hits the ground around 10 seconds. And then my y-min and my y-max, I made my y-min -30, my y-max 420 because I know it goes a little bit above 400. And that all worked out for me. I hit graph at that point, and I could see the function. All right, so mess with your window if you're not seeing it. You should be able to see the whole graph. And then I just do for A, I see when it hits the ground. So I do second calc and then 0. And 0 is the second choice. So second calc 2 is what I type in. I do my left bound, right bound, so left bound, right bound, and then it's going to cross right here. So I guess where that is. And I got 10, 0 as my point there. 0 tells us the height, the 10 is the time. So we just answered, when does it reach its, no we didn't. When does it hit, how long will it take for it to hit the ground? So for A, that's going to be 10 seconds for A. All right. We can go ahead and try question B. How high will it be at 2 seconds? So I'm going to hit second calc value. So that's 1. Second calc 1, I can just type in, it said 2 seconds, so just type in a 2 and hit enter. And I got 256. You could have also hit second graph and just looked at your table. And when your x value is 2, your y value should be 256. So question B, 256 feet. All right, question C, what's the highest elevation it reaches? That's talking about the vertex. So I hit second calc max for that one. And maximum is number 4. Second calc max, number 4. And I do left bound, right bound, and then enter. So left bound, right bound, and then I guess where it is. And I got about 5,400. So that means that about 5 seconds it is at 400 feet. So for C, what's the highest it reaches? I'm going to say 400 feet. When does it reach its highest elevation? That's my x value there, which is my axis of symmetry, which is 5. We could do it by hand, negative b over 2a, and you'd find out that negative 160 over negative 32 is positive 5. So, all right, that's it for number 13. Let's try number 14 next. All right, for 14, the ball is just, an object is dropped from the building. It's not thrown up, and that's our formula. So I just go to y equals, I type in 18x squared, and then I want to be able to see this well, so I hit second graph, and that shows me the values that are going to be important to me for my window. So second graph and then window. This one's a little different than the other one since it's not thrown up, and you'll notice that this does have a positive lead coefficient. So this is just measuring the distance. So I'm looking at my second graph and I want to see when my y value equals 600. And I'm looking at that, and at 5 seconds it's 450. At 6 seconds it's going to be 648. So which one is it closer to 600? Is it 6 seconds or 5 seconds? And I'm definitely getting for that it's going to be closer to 6 seconds for that. Another way to do that, you could plug in your distance of 600, because d equals your distance, and then equals, so again I could just plug in for that d equals 18t squared. D's our distance, which is 600, 18t squared, and I'm just solving for t, so another way to do this is just to use inverse operations. And I got about 5,811 for t squared. And then how do I solve for t, which is our time? The inverse of squaring is square root, so just take the square root of that answer. Whoops, that was 33.3, not 5811 I said, my bad. I think I hit multiply instead of divide. So hit second square root of 33.3 repeating. Or you can just hit second square root, second answer, and that'll give you about 5.8 about? Is that closer to 5 seconds or 6 seconds? And the answer is it's closer to 6 seconds. So A has been confirmed at 6 seconds. All right, check out B with me. How far does it travel after 3 seconds? Using your calculator, you can just plug in 3 for t, just like we did on this last one. Or if you just want to rely on your calculator, hit second calc and then value, and value is 1. So second calc 1, as long as you can see your graph, this will work. So if I hit second calc 1, and I want to know at 3 seconds, so I just type in a 3 and then enter. And it gives me my y value is 162. It's 162 feet. All right, that sums it up for A and B for number 14. All right, number 15 is next. All right, 15 you really shouldn't need a calculator for. I'm just going to draw a general sketch of what this one's going to look like. This is my D value. So D is really representing the X, and then my I is representing my Y. So I know the I is going to be the vertical part, the D is the horizontal part. Now if I know that, and I know I have a negative lead coefficient there, negative 108, so that tells me it's going to look something like this. It's a quadratic, and it's going up and then down. It has a maximum. So knowing that, just describe what's going on. How does the value of D affect the value of I? Well, as D increases, I is also increasing. So you'd say as D increases, so in other words, as D is going further and further to the right, or getting bigger and bigger, notice that I is also going up and up, so it's getting bigger and bigger. So as D increases, we can say I increases until it reaches a maximum. Notice that I will level off there. It has a maximum. Reaches a max. And then, what does I do? Then I decreases. And what is D still doing? D is still going to the right. So as we go further to the right, notice that the I value starts to go back down. So we can say as I decreases, D continues to increase. And you can just say this in your own words. That's not the only way to say it, but as long as you're describing what is actually happening. So as D continues to increase, I increases until it reaches its max right here, and then it starts to decrease. All right, that sums it up for 15. Okay, 16, we're going to type in the calculator. So 16, go to y equals and type the function in. All right, after I typed it in, I hit second graph so I can see what my values are going to look like. And I noticed right away that that it's falling pretty quickly. So my x value only gives me a positive y value from 0 to 2. So I'm going to make my x min, I'm going to go to my window and set my x min to -1 and my x max to 3. And then for my y, I care about when it's above the ground, so I'm going to pick a value just below the ground for my minimum, maybe like -5. And then the maximum is going to be 21 is the biggest number I see, so I'm going to go with 25 and see if that works out for me for my window. Alright, and then I hit graph, and my numbers worked out really well. I can see exactly what's going on. Okay, question A. How high did the football go? That's going to be my maximum, and I do that by second calc 4. So I now press second calc 4, and that gives me my maximum. So I go left bound. I'm just going to draw a little sketch of what that looks like. So that's going to look like this. And my left bound is going to be right there. My right bound's right there. And then I'm going to guess where it is right there. And I got 0.9 and 21.1. And this wants to know the height. So that's going to be this number, the y value. That's how high it goes. So 21.1, I believe that's in feet. 21.1 feet. Okay, question B. Because he missed the pass, how long did it take the ball to reach the ground? Well, the ground is going to be where it hits the x-axis, so right here. So we want to know that value. So that's my 0. So I hit second calc 2 to find my 0. Second calc 2. And when I do that, I want to be left bound right here, right bound right there, and then that's where I guess, right about where it is. Try that. And I got about 2.1 and 0. Remember that number on the right, if you get like an E negative 12, which is actually what I got, that means it's just a really small number, so it's basically 0. And the only one I care about that anyway is going to be my 2.1. So at 2.1 seconds is when the ball reaches the ground. So 2.1 seconds. All right, question C. Evaluate for H is 1.5 and interpret its meaning. Okay, here I just did second calc and then value, and value is my number 1 choice. I just typed in 1.5 and then enter, and it gave me a y value of 16. So for C, I would say it's 16, and that means at 1.5 seconds, the ball is 16 feet above ground, because it's positive. So that's what it means by interpret its meaning. Just say what the numbers mean. So 1.5 seconds at 16 feet above ground. Okay, D, evaluate the y-intercept and interpret its meaning. You do not need a calculator for this. Just look at your constant term. It's 7. So you would say the ball is thrown at 7 feet in the air, 7 feet above ground. So it would be 7, and you could say the ball is thrown 7 feet above ground. And that sums it up for 16. Let's move on to 17. A kickball is kicked from the top of the building. All right, so we have a bunch of data. Our time is x, our height is y. And if you recall from class, we did an activity just like this. And what we did was we typed in all the data under stat enter. So when we type that in, our L1 is our x, our L2 is our y. Type in all those guys. And then you want to type in stat calc quadratic regression. And that quadratic regression, I believe, is number 5. So stat calc 5. Then make sure you hit enter. On your calculator, you may need to hit it more than one time. When you do that, it gives you your A, B, and C in standard form. So I got for that one y equals -5. I'm just going to round these to the nearest tenth. So -5.7. The first term is an x squared term, and plus 57.9. That's actually going to be 58.0 if I round it to the nearest tenth. X plus 10.3. That will be wrong if you're not putting the appropriate x squared in x. You need to know. And it tells you right above, it says ax squared plus bx plus c in your calculator. That would be your answer for number 17. So just do a quadratic regression. Okay, 18. We can do the same thing for that one if we would like. So I recommend just doing the same thing for 18, calling that your x is your L1, your y is your L2. And we're just going to do stat enter, type them all in. I do want to do one thing a little differently here, because you'll notice from your answer choices, these are both quadratics, these 3 actually, and the first one's linear. So I'm looking at that, and I want to be able to see those points. So go ahead and do stat enter, So I'm going to press y equals and then turn on plot 1. So just up and enter. And then I can press zoom 9 and that'll zoom right into my points. If you didn't know zoom 9, you could just look at your values here and use your X-min and X-max, Y-min and Y-max for your window. But if I press zoom 9, I can see that's not going to be linear. Like I see a point there, a point down there, and then it's curving back up. So I know it's not going to be A. So I can mark through A. It's going to be B, C, or D. So now I'll do the same steps I did from above. I'm going to do stat calc 5. That's my quadratic regression. Since I know now it's a quadratic, since I looked at it. And make sure you hit enter. And my A value was 2.95. My B value was 0.27. And my C value's a little over -5. So which one's that closest to? Well, for the A, C doesn't make any sense. That's 1. This is almost 3. So it looks like it's going to be B. Let's just match these y-intercepts. They're right on. So yes, B is going to be my best answer for 18. Notice this does have a middle term of 0.27, but that's almost negligible. It's almost 0. So it's okay that that one didn't have a middle term. All right, look at 19. The height in feet, okay, gives us this formula, and t is the time. And so we know this is going to look something like this. And I don't have a y-intercept that's 0, so it's going to cross like that. And I can type that in. So I'm going to go to y equals and type this function in. After I type it in, I hit second graph, and I'm looking to adjust my window. So my x max, I'm looking at 0 seconds to 2 seconds are the positive numbers, so I'm going to go like -1 and 3 for my x-min and my x-max. My y value, the highest it goes is 29. I want to be just below the ground, so maybe -5, and then I want to be above it, so maybe 35 for my max, for my y max. So I'm going to adjust those in my window. Then when I press graph, I want to make sure it shows up, and mine does. It looks just like the graph I've drawn. Question A, what's the height after 3 seconds? That one I want to press second calc 1. That's my value. You could also hit second graph and look at your table. That's another way to get that one. So second calc 1, and then I want to type in 3 and then enter. And I get my y values -9. So the height is going to be exactly -9, and it says it's in feet. So -9.0 or -9 feet. So question B, when would the object hit the ground? So what did that mean on A? That meant that the ball is actually, or the object is below the ground. So that's after our experiment's done. Okay, looking at B, when would the object hit the ground? That's going to be right here. It's the 0 of the function. So on that one I do second calc 2. And after I press second calc 2, I'm looking for my 0. So I'm going to do left bound, right bound, and then I'm going to guess right in the middle where it crosses. And I got 2.8, 0. So the only one I care about there is the time, which is 2.8 seconds. All right, question C, how high does it get? That's going to be our maximum, which is right here. So on that one, I'm going to press second calc 4 for max. And second calc 4, it says left bound, so that's going to be left bound, right bound, and then I'm going to guess right where it would be. And I got 1.4 and 31.6. All right, so to answer that, how high does it get? That's going to be my y value. The y value tells the height, so that would be 31.6 feet. All right, and question D, evaluate for h equals 0, explain its meaning in this problem. That means if you input as 0 for the t, if you plugged in as 0 for t is your time, what does that mean? What's the y-intercept? That's what it means. So it's the y-intercept, and it says to evaluate it, so that means solve. So if we solve for the y-intercept, it's just going to be our constant. Notice there is no number there for our constant, so it is just 0. So that means that the object is thrown from the ground. That would be answer D. The object is thrown from the ground. So it's not above the ground, it's not below the ground, it's actually right on the ground from where it's released from. And that's what it means for D. Okay, jumping to 20, our last one. A ball is kicked off a cliff and it gives us the data. So this is another one where we have our data but we don't know the equation. So our time is always our x, and our height is going to be our y. So that's L1 and L2. We're going to do the same steps we did before. So stat enter, type in all your data into L1 and L2. And then stat calc 5 is your quadratic regression. And if you want to see these points, you can just press y equals and turn on your plot 1. So stat calc 5, and then hit enter, and it gives you your equation. And then after we have that equation, I'm going to write it down. And I rounded everything to the nearest tenth, and I got y equals negative 5.0. It was really negative 4.99, but negative 5.0 x squared plus 25.6x plus 154.2. I inputted that into y equals in my calculator. And then I press second graph to see the values that are relevant, and my x values for my window, I'm looking at probably hits the ground just before 9 seconds. So I'm going to do, for my x, maybe negative 1 to 10 or negative 1 to 9, something like that. My y values, the highest I see it going is 186. So I'm going to do maybe negative 20 because I want to be below the ground, to maybe 195, or maybe I'll do 200. So something like that should work for my window. I went ahead and pressed y equals and made sure my plot 1 was on, and then I hit graph, and I could see it clearly going through those points. That's just a way to check that I've done everything correctly. And then to see how high was the cliff, that's going to be, I'm going to draw just a generic picture of what I saw on my calculator. Looks something like this. So how high was the cliff is going to be right here. That's the y-intercept. So looking at my function, and I can see it right here from my data, and it's technically not wrong or right to do it either way. Both of them are right. So my y-intercept from the actual quadratic was 154.2. From my actual data, it was 154. I'm going to use the 154.2. I would accept either of those to be correct. And then for B, for the height at 3 seconds, I'm going to press second calc 1. So second calc 1 for my value. I'm going to type in 3 and then enter, and I got 186. So that's 186 feet. And then for the last one, how long did it take for the ball to land in the ocean? That's the 0 of my function. So second calc 2, and then left bound, right bounds below it, and then guessing right where it is, and I got my x value is 8.7 about, comma 0. I just care about the 8.7. So that would be 8.7 seconds. All right, just a little bit of time left. Let's go back over our answers. All right, number 12, that's what my graph looks like. It's 0, negative 8, negative 1, negative 1, negative 9, negative 4, 2. Number 13, we got 10 seconds, 256 feet, 400 feet, and 5. Number 14, we got 6 seconds and 162 feet. Number 15 we got is d increases, I increases until it reaches a max and then decreases.